then you're going to not understand. So looking at the first problem here, we've got 4x plus 1/3 y is equal to 3. We said that we want to solve and graph all of these equations by changing them into slope-intercept form. So obviously that's the first thing that we need to do. What is the first thing in terms of putting it in slope-intercept form that we need to do for this problem, Noemi? Perfect. Do the additive inverse to get negative 4x to the other side. This clears away any non-y terms. And leaves us with 1/3 y is equal to negative 4x plus 3. Our y is not alone yet. We do not have this in slope-intercept form. There is another inverse operation that we must do. Ms. Baker?
Multiplied by the reciprocal.
Multiply by the reciprocal. Now, when I multiply one side by the reciprocal, I need to multiply the other side by the reciprocal. Emphasis on doing multiplication on both sides. Now, when I multiply the right-hand side by 3, which part do I need to multiply by 3? Haseen?
Both.
Both. It needs to be distributed in. That's why we put the parentheses there. That leaves us with y is equal to negative 12x plus 9. Now that we have this in y equals mx plus b form, we just need to correctly identify the different parts of that. So first we'll identify the slope of this line is what, Patricia? Negative 12 over 1. And the y-intercept, Cache, give me the coordinate pair. 0, 9. Perfect. So we're going to go over to 0, 9. And then our slope is negative 12 over 9. So the reminder that we need for this one is we didn't really deal with a lot of negative slopes yesterday. Remember, this tells us a negative rise of 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And a run of 1. Now, we aren't able to reasonably fit a second or a third point on this graph, which isn't particularly good for us in terms of being able to draw a straight line, but we'll have to live with it. So we can only graph, in this case, the 2 points. It's good enough for a line, but if we really want to draw a straight line, usually we want to go through 3 points. I did not use a straight edge. You should. Okay. Now, are we done with this problem yet?
No.
No, because we want to know for certain as we walk away from this problem, did I get this right or did I get this wrong? Haseen, what am I going to do to see if I got this right?
You need to check it, right?
How are we going to do that?
You need to get the little dot, you know? Like
Yeah, pick the point. Now, does it matter which of these 2 points that I use?
no. Yes.
Yes, absolutely. Which point do I absolutely not want to use? Absolutely not want to use, Frida? The y-intercept. So that leaves us with only one other option since we only had 2 points, and that point is here, 1, negative 3. So I'm going to come up all the way back to my original. I'm going to write down 1, negative 3. Those are the points I'm using. So that means my x is 1. So that's 4 times 1. And my y is negative 3. Plus 1/3 times negative 3. Is equal to 3. All right, 4 times 1, that's 4. 1/3 times negative 3 over 1, that gives me negative 3 over 3, which is just negative 1, is equal to 3. 4 plus negative 1 is indeed 3. We know that we got this problem right. No big deal there. Moving on to the next one. Now the next one has decimals in it. There are going to be some very small detailed things that you really have to be focused in on. Please don't lose your brain and pretend like for a second that you cannot pay attention. We got to this point in the previous class, and about half of the class stopped paying attention and being focused on what was going on. As a result, about 75% of the class was completely lost. I don't wish that upon you because it ended up being a 12-minute lecture about paying attention thereafter. So, looking at this particular problem, again, nothing's going to be different about it just because it's decimals in terms of the big picture of what we want to do. We want to get this into y equals mx plus b form. So what am I going to do to start getting myself there, Patricia? We're going to distribute. Before we do that, we'll go ahead and do our leaf chain switch. And we'll distribute this 1.5. So 1.5 times x is 1.5x. Plus negative 1 times 1.5 is negative 1.5. Okay, nothing unusual yet. Next thing that we need to do. Monica M. How so? By adding a positive. Excellent. So negative 0.6 plus a positive 0.6 is equal to 1.5x plus negative 1.5 plus 0.6. We've done this before. We just need to make sure that our brain is engaged. 1.5x. Negative 1.5 plus 0.6. Like signs add or opposite signs subtract? Subtract. So we need to make sure that we're doing subtraction first of all and lining up our decimal points. We also need to take the sign of the larger number. I should already be able to tell that the sign of our larger number is negative. So I'm going to put that down even before I do the subtraction. So I get 0.9. Okay, we've got it in slope-intercept form. At this point, nothing unusual except when we're getting ready to start writing down these parts. The slope is what? Perez.
1.5 over 1.
So we're putting 1.5 over 1. However, we do not really do counting in 0.5s. Or if we run into other things like 2.4s, we don't want to do counting in 0.4s or 0.5s or 0.6s or 0.7s. That's way less accurate than being able to count in whole. So we need to find a way to turn this fraction into a whole number slope. I don't want to lose you right now. Anybody have any ideas how I can change this into a whole number slope? Michael, what do you think?
You just round it up.
We cannot just round. That is rounding. That makes things imperfect. That would be even less perfect than just trying to guess at 0.5s. Jordan. Okay, he's saying 3 over 2. How did you get there?
Because times both by 2.
He multiplied top and bottom by 2. Just like any other fraction, we can recognize that to make the top a whole number, all we need to do is multiply by 2. 1.5 times 2 is 3. Bottom times bottom is 2. Now, a lot of you aren't going to immediately always recognize what you have to multiply by to get the top number to be a whole number. So let me give you a hint. One way that always works, remembering that every time you multiply by 10, that moves the decimal one place to the right. So you can always, no matter what the decimal is, try multiplying by 10 over 10. That's going to move the decimal once here, move the decimal once here. That gives me 15 over 10. At this point, we have a whole number slope, but we would need to do what to get it back to the 3 over 2? Simplify. So it's easier to know the smallest number that you need to multiply by to make it a whole number, but if decimals are involved, you can always multiply by tens. You might have some simplification to do afterwards. So our slope here is 3 over 2. I'm going to rewrite the equation with a fractional slope. So instead of 1.5x, I'm going to put what? 3 halves x plus negative 0.9. Okay. What's our y-intercept? Jalil.
0.9, negative 0.9.
So what are the coordinates?
0, and x is 0,
Mm-hmm.
and y-axis negative 0.9.
Negative 0.9. So we worked a little bit with this yesterday, but we didn't work with any problems quite like this one, and we're going to talk about why. So when we flip down to the bottom, negative 0.9 is going to be where? I'm zoomed in really closely here so we can talk about this. Negative 0.9 is going to be where, Edwin? Okay, so really, really close to the negative 1 box. So I'm going to put it here. Really, really close to that negative 1 whole. That's not so bad. We definitely talked about that yesterday. Now, here's the next part that becomes really interesting. We didn't have any yesterday where we did rise over run that were decimals, and we ended up rising over run past the central axes, the x-axes. So when I move 1 whole from negative 0.9, thinking about this, when we're moving up 1 whole, all we're doing is adding 1. So if I am rising 1 from negative 0.9, where will I be? If I rise if I rise 1 from negative 0.9, where will I be? Frida. 0.9 is what a lot of us would think, and this is why we bring up this problem today. Because if we think about it, if we have negative 0.9 plus 1, Quintana, where are we actually going to end up? 0.1. So we have 1.0, opposite sign subtract, minus 0.9 gives us 0.1. Take the sign of the larger number as positive. So as we come over here and we rise 1, we end up at 0.1. So that makes that ever so slight change. When you're crossing over the axes, you have to think really, really carefully to what that addition is doing. Now from here, now it's really easy. 0.1 plus 1 is 1.1. And 1.1 plus 1 is 2.1. So that's our rise of 3. Keeping in mind our y coordinate right now is at 2.1. Now we need to run 2. That's really easy since we're already on the axes. Run 1, 2. This is our second point. The thing that confuses people the most is being able to write down the coordinates that we are now at. What is the coordinate pair for the point that we are now at? And this is where this skip counting and thinking through and counting through your rises over your runs while you're doing them. Where are we at, Jordan?
We're at 2. Wait. Yeah, we're at 2 and 2.1.
2.1. So if you get to that point and you get to the end and you can't remember where you're at, go back to your counting. From negative 0.9 to 0.1, 0.1, 1.1, 2.1. 0, 1, 2. Okay? However, we want to go ahead and do our third point. This one's going to be a little bit easier, starting with our rise. 2.1 plus 1 is 3.1, 4.1, 5.1. So we know our y-coordinate is going to be... Our y-coordinate is going to be 5.1. And our x-coordinate, we started at 2 and we're running 3, 4. So those are our 3 points. Take a straight edge, straighter than I can draw. Freehand. And we have those 3 points make this line. Now, am I done with this problem yet? No, because I want to know before I move on from this problem indefinitely that I got this problem right. What is it that I need to do to prove to myself that I absolutely, positively got this problem right? Patrick, check it how? Okay, yeah, plugging in the numbers from the last coordinate that we got. So, Patrick, what are you going to plug in for y? Okay, so that would be using the second point. What about that third point? That's the one you said you wanted to use. It's okay, we can use that second point if you want. You just need to choose. Okay, so you want to use 5.1 from the last point. That's totally fine. So we're going to have 5.1 plus negative 0.6 is equal to 1.5. And what are we plugging in for x, Patrick? Go back to your point. Where is it? What's the x value of that point? 5.1 plus negative 0.6, as Haseen told us, is 4.5. Doing this order of operations, we need to do what's in the parentheses first. And 1.5 times 3 is going to give us 4.5. It's equal to 4.5. So in this problem, there are a handful of details that we really need to make sure that we're paying attention to. Number one is that if we end up with this slope that has a decimal in it, 1.5 over 1, we have to do something so we can get a whole number slope. So Jordan originally said multiply by 2 over 2 because he knew that was the smallest thing he could multiply by. I told you alternatively, if you don't know what the smallest thing is to multiply by, Desiree, you could always multiply by what? Patrick? 10 over 10. Because that's always going to move the decimal at least one place. The other thing that we really needed to focus in on was doing our counting for our rise over our run. If we're starting at a decimal place, it's not as obvious when we do that counting. If you started at a decimal place and you cross over that x-axis, you need to really think about where you are going. It's not going from negative 0.9 to positive 0.9. That's a difference of 1.8. Okay? Have to be super laser focused if you're crossing over those axes with decimals. All right, last problem. Desiree, what's the first thing that we need to do? Before we distribute, I'm going to go ahead and leave chain switch. Gives me Gives me 3/4 y plus -5 is equal to 1/2 x. -4 times 1/2 gives me -4/2, which is -2. Then what, Noemi?
You put positive 5 on both sides.
3/4 y plus -5 plus 5 is equal to 1/2 x plus -2 plus 5. 3/4 y is equal to 1/2 x plus 3. Now what, Cache? Sorry, I can't hear you. By what? One half times 4/3. I'm going to do some cancellation beforehand. It's going to leave me with 2/3. And 3 times 4/3. Cancel, cancel, gives me 4. Y equals 2/3 x plus 4. That should be a simple one to graph. Over here to 4. And rise 2, run 3. Rise 2, 1, 3. Yes, Jordan? Now we got to check. Liana, what point would you like to use to check? Give me the coordinates of it. I need the coordinates of the point that you're planning on using to check. So it seems that she has chosen this point, 6, 8. So Liana, what am I plugging in for my y?
8.
Good. Plus -5 is equal to 1/2. And what am I plugging in for x, Liana? 6. So 3/4 times 8. Doing that simplification beforehand, I'm going to get 3 times 2 is 6 plus -5. It's equal to 1/2 times 2. 6 plus -4 is 2. This gives me a positive 1. 1/2 times 2, also a positive 1. Questions?